Hello everyone. So in my first video I gave a little introduction to data science and R, and so in this video I'm going to do the demonstration of R in action. So I will be operating on football data, which is from profootballreference.com, and I am using RStudio to manage my code and display what's going on. So we'll just go right through this. So first of all, I'm going to be reading in HTML tables. So I need to import this library. So I do so. And then I am going to be creating some tables. So this table here has all the football team names and also the abbreviation that's used for the URL. And then I'm combining this all into one single table. And then creating names for that table that will emerge. And so you can see them all down here. These are the columns that I'm going to be bringing in. Since I'm a Seahawks fan, I will be gathering data from the 1976 onwards when the Seahawks started. So I'm right here doing some variable assignment, creating some data frames and storing them in these variables. And so you can kind of see what's going on over here. So now I have a for loop, and this for loop is going to do many different things. It is going to do some data type changing, and then go out to the web. And for each of the football teams, the name and the year, 1976 to 2014, it's going to pull in the data for that team and bring it into the table, do some conversions, adding the data into the tables, and so basically I'm just trying to bring it in. And then down here I created a little print statement so we can just monitor the progress. So this for loop that I create here just goes and gets all the data. So here I'm going to run it. So I've stored that into memory, and now you can see down here it is going out and grabbing the data. So it takes a long time to grab all the data. It'll do this for the 32 teams for all the years between 1976 and 2014. So I'm going to pause the video and then come back when this has finally completed. Welcome back. So as you can see, the program, the for loop finally completed, and now we have all of our data. So that's the data in this game scores table. So if I click on that, you can see the sort of data that we have. The full name of the team, the URL name in order to get the data by going out to the web, the year that the row is from, which week, day, date, box score, just throwaway column, whether they won or lost, whether they went to overtime, the record for that game, home or away, who they were playing, and then their score, their opponent's score, first downs, total yards, passing yards, rushing yards, turnovers, and then the opponent's data. So I got this for all of the teams for each year since 1976, and you can see that there's 20,240 observations. So now we can actually start doing some work on it. So I'm going to do some cleanup first. So pass that in, change some of the names for the columns. I'm going to remove the empty rows. So now you can see we now have 18, well, basically 19,000 rows there. And I'm just going to save this data to a different variable so that if in the event that I made a mistake, I could always go back and reload that data set, wouldn't have to get it again. So now here's an example of a user-defined function. So it's going to do a lot more cleanup and moving things around. So here, for example, I select only some of the columns in the table for use. I reorder them, and then I change the data, which was stored as characters or factors in R, and make it to numeric. So I'm casting the data type from one to another and making it a numeric data type. Changing up some of the tables, the values. For home and away, use ones and zeros instead of the @ symbol that was there previously. Replacing missing numeric values with 0. So that way it cleans up the data so it's easier to use. So I'm going to load this function here. So as you can see, it gets loaded, and now it's available for use. And now I can call the function clean game scores and have it operate on that table. So I do that, and I now have this numeric table, which only has 12 variables. And just clicking on that, you can see this is all the data. So I got rid of all the textual data and just have numeric values. So now we can go and explore the data. So let's do some example summary statistics. Here we can see that for our team scores since 1976, the highest score was 62 and the minimum score was 0. Median is 20, average is 20.88. Most teams get around 18 to 19 first downs in a game. The highest passing yards was 522. The minimum was -39, so that's pretty bad. Rushing yards -18 through 407. And turnovers, minimum of 0 and a maximum of 11 turnovers in one game. So those are some summary statistics, and I can again take those averages and assign it to a variable. So that's what this is, and now I have this array, which is just the averages. So let's take a look at what this does. This looks at the team scores and gets the average, the mean, for all the games that are at home. And you can see the value is 22. And if I do the same for away games, the value is 19. So it looks like a home teams on average score more at home. So that's the home advantage, which is worth about 3 points. Now we can also do other things like plotting. So this would give us a histogram of the team score. So let me plot that. And you can see over here that here's a plot of the team score frequencies. You can see there's most common for teams to score in this range here, but there's some very high numbers as well as low numbers. And we can also display this data numerically in a table format over here. So you can see 384 instances of 0 and 3 instances of 62. We want to see what is most often scored. Well, that's going to be in this range here, so looking around the 20 through 16, 17 range is probably going to be 17 right here with 1400. So if we apply this line here, we can get the max and then determine which one it actually is. And so that prints out, yes, indeed, 17 is the most often or frequently scored team score with 1,473. And we can do a plot. So I'm just adding total yards here, passing yards versus rushing yards. And then we can plot the total yards with team score. And we can see that total yards and team score are pretty, not perfectly related, but, as total yards goes up, the score goes up, which makes sense. The more yards a team has, the higher their score is likely to be, because they're moving down the field very often. So from here, we can start doing some modeling, but I'm going to pause the video and restart again.